Good morning, everyone. Once again, welcome to this training series that we organized in collaboration with the Nigerian Space Research and Development Agency and Digital Africa. So I'm Joseph Tishimire, and also I prepared the presentation and demo in collaboration with Kenneth Mbeya, who's my current boss in charge of capacity development within East South Africa. So yesterday we discussed about food security. I mean, overall introduction on the Africa platforms, and today we'll be focusing on agriculture and food security as per our training plan I described yesterday. Please allow me to switch off my camera to because my internet is that strong. So I won't take much time on this in, about the Africa background. As Dr. Rade told me, we have to close the session by 11 because most of the team members have other internal commitments for today. But just highlighting that South Africa is there uh, to uh, to capitalize the potentials of freely available Earth observation data sets, and that's why we put in place a public infrastructure through which you can access those data in analysis formats. And of course, also we try to empower the capacities um, to empower governments in the use of the data sets to inform several initiatives, including climate change mitigation and adaptations, food security, to look at the day, and of course the SDGs. So we thank partners, including Afrigis in the region, that have been very instrumental in identifying uh, key partners, assessing users' needs, the co-development and validation and service and the products, their dissemination, even capacity building, and also we thank partner institutions, especially national space agencies like uh, NASRDA, who have been very key in uptaking and improving our data platforms. So far, we have approximately 12 petabytes of data sets that were developed in collaboration with the partners with the continent. And today, we'll be mostly focusing on the three products in the middle. That's the crop external map, functional cover, and the climatology, yet to inform the crop trends and the vegetation trends in general. So everything is free, even for commercial use, from data analysis ready data sets, um, uh, code creating space, related codes, even the capacity building. And we can start small uh, or simple topics to complex workflows that could help us to monitor civil phenomena across the continent. Our aim is to transform data to into insights to inform several decisions, and through an open data cube, you can access your data sets, and even within our sandbox, you can access to a lot of pre-developed Jupyter Lab libraries, and that way we can either customize them if a good programmer, even be able to specify the time scale and the spatial extent and run analysis, and be able to export the results. So once again, we are trying to provide the information data that could us to have relevant information and insights to address social, environmental, and economic changes on the continent. So interfaces, we talked about map and the sandbox. I introduced this all this yesterday, and uh, and the most importantly, for food security, it's a way of mostly understanding um, the trend in vegetation in greeners using accurate proxies like the enhanced vegetation index and the normalized difference vegetation index. And this could help people to accurately define areas of farmland that's been sold in harvest, and of course improve food production. And this was uh, co-developed with different institutions across the continent. The crop prediction map, this is very key because we're able to understand the external crop areas on the continent, and from probability of cropping and even value cropping map. So if I go uh, to our the Africa uh, maps, you can see here, you can type to into your browser www.southafrica um, maps.southafrica.africa. I've shared the link in the chat. Once again, I suppose the news yesterday. If we try to go to Nigeria, you can we can see some our data sets, and you can explore the agricultural data set when you have the crop extent map. This will show our cropped areas across the continent. And if someone would like to suggest any area in Nigeria, like here around uh, Kainji Dam, you see a lot of crop plants here. And all those, you can zoom in and see if these are crop plants or not. You can even switch off to see the background. You can see those farmlands uh, around this Kainji Dam. And not only you can see if they are cooperants, but also can check the probability of cropping, areas with high probability of cropping. And you can see on the map that at least our areas here have high probability of cropping. And this makes more sense because around the river and then around the lake, and then the irrigation is possible in this area. This one a way of checking the crop or the cropped areas in any region, like this around KG dam uh, uh, in Nigeria. And I can once again share the link with you just for your own exploration. I post it in the chat. And once again, so it's a bit heavy, but it will definitely display. Once again, we can also check the greenness of an area. Let me refresh the window. We can also check the greenness of an area using other vegetation proxies. I can use our datasets, our annual geomads here. Next Sentinel can zoom around our studio area around here. This one we were kind of exploring, if I'm not mistaken. Can even take this south, southern part, and This is a mosaic that was derived from Sentinel-2 images, and from this mosaic, it takes longer to display. This depends upon the internet connectivity. Please be patient. And from this mosaic, we can use a vegetation index as a proxy. Here can use the NDVI, that's the normal difference vegetation index, and could show us some cropped area should be greener than others. And once again, this is the annual summary, and you can do a comparison from one year to another. You can compare 2017 and compare it to 2024. It's 2017, it's 2024, 2017, 2024. We see that 2017 looks greener than 2024 if we try to compare. And this is a very rapid way of exploring the vegetation, uh, uh, the vegetation cover, or even vegetation greenness in farmlands, but also we can use other uh, uh, other ways. We can use this rolling geomads. That's the kind of monthly mosaic. And on this, if someone could tell us the seasons, we can compare different seasons and see how this works in Nigeria. But this is for the month of July. We check the NDVI, and it may take longer. You can see that July is green. Maybe if you compare maybe July to January, if you compare maybe um, let's say for 2024, we compare January. Sorry, that's strong. If we can compare January to July, okay, just be July 2024, same year. This is the intention that strong from my side. Okay, you can see this is January 2024. When you come back to July, you can see that July is very green, and to me that this may be a kind of a good season when the NDVI is at the optimal uh, state, if I can say. So this is a way of exploring immediately using the D-Africa maps, but also we can go to the sandbox. Into the sandbox, there are a lot of notebooks that could help us to explore the vegetation health. Uh, Once again, when you have the sandbox, we have this many folders, especially beginners guides, datasets, frequently called load examples, SDG, supplementary data tools in these cases. And within each folder, there are well-structured notebooks that help you uh, to do your analysis on a simple click. You have just to know the time scale and also the spatial extent of your study area. And once again, uh, yesterday we discussed about how we can use the sandbox. The idea was that if you have your account, you just log in, but if you don't have your account, you just sign up. And most of you were able to create the sandbox account, except two that was yesterday evening, and one who is being assisted right now. And Once you have your account, once you have your sandbox account, what should be next? Um, it's simple. You go, so you get into your sandbox immediately, and when you open your sandbox, there is this uh, landing this landing page, as you can see, and from this landing page, there are several information on the use of the Africa sandbox and the documentation via GitHub. How can upload and download is download files, upload and download files. How you can connect sandbox to your Google Drive, and uh, and also the terms and conditions for the use of the sandbox. And once again, sandbox is a cloud computing space. It's very temporary and not a permanent storage of your files. You will not be able to save your changes between two sessions. All changes will be erased as long as you log out from the sandbox. That's why you should always find a solution to back up uh, your work either to your Google Drive, either connecting your sandbox to the GitHub, or even trying to download your notebook, keep it on your PC, and then upload it once you open a new session. This is very critical because it would you can lose your work. And of course, before you download your notebook, make sure that you save all the changes. When you go into the sandbox, there are our notebooks are grouped either by SDGs. So, and on a single click, you can see that our notebook may are grouped by SDGs, and each notebook is classified depending upon the indicator it can contribute to. So now we are talking about food security. This is mostly SDG 2. And then we have a lot of notebooks that prepare to understand to monitor the agriculture, vegetation trends, and food security and vegetation in general. And these are the notebooks we'll be mostly using for this case. But also, they're also grouped by themes. There are several themes, and now we'll be focusing on agriculture and vegetation. And all these notebooks were developed and are freely available that to inform agriculture and food security uh, at continental level, even at national scale. So, but most importantly, if we go back uh, to the presentation, you will see that from this sandbox, we can do several analysis from understanding the vegetation anomaly, vision phenology, even we can go until developing a vegetation crop forecasting and vegetation conditions model. And for example, we have a notebook we call crop health that is importantly very easy to manipulate, which is under the old examples folder. And we'll start by this just to understand the crop extent, even the behavior of several fields, uh, several plots in one field. So once again, you go to the old examples, then you could go down, ignore the number, the crop health. Once again, you can duplicate the notebook and then give it another name. Just make sure that you are saving your analysis in a chronological order. Even this is very key for data management purposes. And once you've, for me, I've duplicated it and I've named it Crop Health Nigeria. And once you go inside, you'll be able to find the title of the notebook, the keywords, you're using select two data sets, and the background is that using this notebook, we can identify the trend of the different fields, different plots in one field. It should be a way of identifying or investigating poor performance of some fields compared to others, but also scout uh, for disease damage. Imagine you've used the same uh, inputs, you've used the same agricultural practices, and you don't have the same performance among your fields. Either there is water stress, either there are crop diseases, or even practices were not respected, then you should go and cross check from the field. This unless you rely upon the NDVI, and we can understand whether our field behaving well or not. And if not, try to put in place intervention measures. Of course, we collect the data cube and import the function. We're using the application called crop health, and then we should define our study area and using the active sheet or buffer. And then what I did, I used this um, uh, uh, coordinates I'm going to share with you in the chat. So that if you use the same coordinates in the notebook and the same buffer, we can have the idea of on the area we are going to work on. So once again, what you can do, we can switch to our maps and even try to insert the coordinate and see the exact location from the Africa map that you can get an idea um, on our. This is the study area we are working on, and then what you can do. Once you need to go for full screen, and the analysis was on the year that 20 August 2023, and we can load the application for our location, the study area, and then we can run the function. But it is I should start and run all cells on the scratch so that because those cells are run in a chronological order, and the first cell serves as input to the second one to the third, and then the third to the fourth, and then the fourth to the fifth. That's why it was giving an error. Let's be patient. The system is loading the certain data sets, and then the they said that is giving an error, but I don't know why. But the idea was importantly that is not good from my side. But the idea was that we can identify this was study area, and it's supposed that all the plots should perform the same way. And using an DVI, we can uh, generate a time series for all the plots in this field, and all the spectral signature for each plot, we see the behavior almost the same. It means that all the crop practices are almost similar. And of course, we'll see some data missing. This is uh, this is this is an issue, especially when you use optical data sets, because they can be too cloudy to be included into our models, and then they are left out. And of course, for robust computations, should have a way to interpolate um, this missing data. And then, if fields don't do the same way, it should be up on us to go on the field and cross check the reason behind the poor performance of one field compared to others. But also, we can try to measure the vegetation phenology. This is always our study area, but increase the buffer from zero point 0.2 to zero point 0.4. And for from the year 2022 to 2024. And we can use NDVI or EVI to understand time series, and also to do a interpolation for the missing data, and of course try to understand the crop statistics in general. And of course we mostly work on the crop croplands that were masked using our uh, recent settlement product on cropped area mapping in Africa. And of course, the same notebook is located under the examples folder, and you can use two notebooks: the phenology using optical datasets, that is especially the Landsat and Sentinel dataset, and also using the ROIDA. ROIDA is mostly the Sentinel-1 datasets. And once again, the cloud cover may be an issue for some region. For example, can you see this image of 14 August 2024 is very cloudy. The same if you see the image of 11 April 2024, similarly, it is a what they called cover, but you can see the image of 2nd April 2023, it's clear, and while the image of 22 December 2024 is clearer. So this always shows affect analysis. And if we try to generate a time series, once again, we see the trend is good if you compare our work from 2023 to 2024, or you can see that where the peak here somewhere around December, and September to December and to December. But once again, a lot of data are missing. I think that our point is very cloudy. And if we try to interpolate, you can see even for almost for the 2023, we have very few data sets, but you can still interpolate. You can see the trend. The peak is around November to December, and this gives an idea of the time start of the season, and also the peak of the season, end of the season, end of the season, peak of the season, end of the season. And for once again, this shows us that the optical uh, sensors are not a good solution to study phenology in the study area. But just for this study area, but you can go to the other area, you can find clear images for people who are familiar with the geography of Nigeria. And also, you can also compare 2 years. I tried to compare 3 years, and when 2023 data were missing, the start of the season almost the same. It can be almost further, and you can see the curve was not clear enough once again for our region. But Even if you see other statistics like the phenology at the peak of the season, Olivia is around 8, which is good. While the amplitude of the season not that big, and also start the season, Olivia is yeah kind of planting. Olivia is smaller, is uh, is lower. While end of the season also we are almost about harvesting, and it should be short, smaller equally. But if we use the Sentinel dataset, which could penetrate the clouds, these are very important as they can help us just to, if we see this time series is complete because it is derived from radar datasets. That's one. And secondly, we can generate a smooth time series from 2023 to 2025, showing clear peak of the season. And you can see 2024 has a higher performance and DVI beyond 8, while others were around 8. And we can also separate year by year using the for our time series. And lastly, we can compare several years, and you can see uh, compared to the optical sensors, this radar sensor could show us our the 3 years, 2022, 2023, 2024. The behavior was more or less the same from the start of the season, peak of the season, even only the season. This means that planting practices in the area uh, remain the same in terms of crop types, um, uh, uh, planting and harvesting times remain almost uh, stable in that region. The same always the RFDI, the Road Vegetation Index, shows uh, a, a high peak during the peak of the season. Why, of course, start the season before the plantation is uh, is uh, is the RVI is very small, and of course, we can go to several statistics there for the season and even until the rate of senescence and rate of growth and so on. So when we compare the two curves, um, you can see the optical data sets may differ from the the may differ from the radar uh, that's from radar data sets. So now we go to the phenology optical. As I said, the same notebook is located in the Redwood examples, and it is called um, the phenology, uh, the phenology optical in this uh, folder called the old example. This is phenology optical. You once again duplicate it and open it in the window, and then it has the intro. It combines the Sentinel-2 datasets and also the crop mask, and it able to use uh, the landsets, the Sentinel datasets to derive a NDVI time series, and you have all these stages, loading datasets for all of interest, calculate the proxy and NDVI, do a zonal time series analysis, complete the instrument vegetation time series, create phenol statistics, create per pixel phenol statistics, And of course, we can also write generic temporal statistics using time and to import to collect data cube to so it's package that about to do this partial data sets by that we're about to make some plots and do the with the numbers tables and so on do the geometry and produce beautiful plots and define area create indices raw data set display data interactive maps uh, convert data from raster to vector and from vector to raster, and then do the phenology. So the function is vegetation phenology, and you specify our our study area and also the time scale, and our study area is here, as you can see. Um, the study area we're working on, and then we can load our sentinel data sets. You can see it shows us, it tells us we have 152 sentinel images available in the archive, and then we can adjust uh, the data, keep the data to the extent of our area of interest. Um, Someone is saying the position set and the audio keeps going on and off. Sorry for this. How it's done for me, I think it's okay. Could everyone confirm if they see the presentation? Except Awin Dunk. Sorry for that. And also we can route our crop masks as to mask out all non-agricultural runs, and then you can start to visualize some of the images from the term series. As you said, you can see some of them are cloudy and others are not. We calculate the proxies being NDVI or EVI using the formulas here, and then we can generate do zonal calculations to have this time series with a lot of missing data, as I said. For our example, we can smooth our time series within the available data sets. And then lastly, we can produce uh, the comparing years. It's not possible because most of the data were missing actually, and also can do the phenology which did not run because of the internet. But for the same could be done using the optical sensor that is Sentinel-1 beta. The processes are almost the same, except some processes that are only for radar datasets trying to deal with the polarization of radar datasets because you have the vertical polarization and horizontal polarization and try to convert uh, into uh, digital uh, numbers, and then we have love game. Any questions? Okay. Then this is the term series you can produce, and later on we can compute the radar vegetation index using this formula, combining the vertical polarization over the the horizontal polarization over the sum of the horizontal and vertical polarizations. And this is the term series. And then we can smooth our term series separate year for year. And lastly, we can once again uh, visualize the term series per year just to compare 1, 2, or several years to have an idea on the vegetation practices in the study area. And then we can also produce per pixel statistics. Once again, once again, uh, this is a kind of analysis that we definitely do our work, but we have a lot of other notebooks like of forecasting vegetation conditions using an autoregressive moving average model. And this model is very important because it takes into consideration some exogenous variables. You can see from the trained model and the test model, the predictions are enough reliable to for the prediction or the forecasting of vegetation conditions. Once again, you can understand the vegetation anomalies, trying at centimeter resolution, and this product was derived from Sentinel-2 and Landsat, and you can have this monthly mean NDVI for any month of interest we want on the continent. And of course, we can have other statistics like uh, the standard deviations and the size anomalies, just to understand how the NDVI is behaving compared to the expected of annual or monthly average in any region. And if applied to cropped areas, it could also give a key insight on the vegetation health. Set of tutorials here, including the drought index, crop health, even how the soil moisture and even flood risk and water scarcity or availability could affect the crop health and the phenology, and also some work on the monitoring of rangeland health that to improve the health and diversity of wildlife in any region. This there was an example of the northern Kenya, but I think also comparing using the same methods like modified soil adjusted vegetation index, the NDVI and the AVI, we can try to generate technology maps that could inform the management of rangelands, even in Nigeria, especially in areas with a large number of pastoralists, and this should us to manage efficiently all those rangelands. Also, try to use this almost the same approach to uh, uh, inform some production of key crops. This was the example of guys in Ghana informing the mango production based on the annual phonologies, and they could be able to predict the right month for harvesting if there will be shift or not, and then you can even forecast uh, the yield in the future, but also put in place adequate agricultural practices. So this is a simple way of kind of communicating results, simulating simultaneously the climate trends, even solar trends, with the NDVI even vegetation is, as you can see on the graph. And this case of Madagascar. And but most importantly, this is a good way to inform uh, the high level decision makers who don't have enough time to go through all readings, 5 pages or 10 pages report, but just on small visualization, you can just get an insight on what's going around in any region and take uh, somehow informed decisions. Also, the land degradation work done with the OSS in Burkina Faso, trying to understand the level of degradation. If there have been degradation, they remain stable, even if there has been restoration over time. And this inspired a course available online. And through this course, you can understand the land cover classification, forest monitoring, urban area mapping, and the certification. And through this drive, through this link, um, maybe I can share it with you because it's very key. Through this link here, we have uh, we have uh, a lot of notebooks that we use for this module from NDVI land use and cover validation, NDVI land cover forest fire monitoring, and so on. And you can have a look at them just to enjoy the beauty of the Africa platforms. And of course, here the case of Ghana, we try to see the level of land degradation over years, and also it's going to inform us about the status of land. Also, the mining explorer, exploring the impacts of mining on natural vegetation. So the case of Pamplama Forest Reserve in Ghana, for which with the Ghana statistics and the Environmental Management Institute, we were able to inform the trends, even impact of mining activities known as GLAMSE on the natural vegetation cover. And of course, you can understand areas that were affected by mining on an annual basis, but also the size of vegetation that are impacted. The same, you can map uh, some fire hotspots uh, using the normalized boundary ratio, and this would be able to optimize fire intervention measures. And all those notebooks I was talking about are always in our sandbox, and they are freely available via our GitHub. When you go to GitHub, Africa GitHub repository, we have all these notebooks are available, and what you can do, it's you can go to the load examples, and the bunch area notebook I was talking about, it's also equally available into the sandbox. Also, the forecasting vegetation condition notebook is always available via our GitHub repository, and how these models are built and how they are validated is the same. Latest statistics, you can find everything uh, in the Africa sandbox. And once again, the notebooks I was telling you about um, uh, boundary area mapping and so on are freely accessible. Please feel free to explore the platforms, and of course, Most of what you do is available online. This is example with the journalism hub. Even these videos will be equally accessible on our YouTube channel. So feel free to go back, explore the tutorial. Uh, our learning platform remains open, just at your pace. And of course, every Wednesday we are meeting for the live session. And we thank everyone, especially uh, the Nigerian Space Research and Development Agency and everyone here present on this call. And for more information, please reach out to us either by scanning the QR code, even by sending an email to myself, Joseph, and also to Ken from Ubeya. We get back to you as soon as possible. Thank you, everyone, for comments, intervention, and so on. You are the most welcome. And I see that we still have almost 6 minutes. And anyone with a comment, intervention, the floor is yours. Thank you.